All right, in this lesson, we're going to do chapter 1, section 7. We're going to do linear inequalities in one variable, and we're also going to do absolute value inequalities. All right, so maybe you remember this from Algebra 1. We have inequalities that are going to be solved exactly the same way as you would an equation, right? A linear equation. All right, so it's the same exact rules, except when you're multiplying or dividing by a negative number, the direction of the inequality symbol flips. All right, so for example, if I have negative 2x is less than 10, you would divide both sides by negative 2, and then you would get x and then a negative 5, but the direction of the symbol would flip, right? So it would become x greater than negative 5, right? So that's just an example, right? We divided by a negative. All right, now your answers can be written as an inequality statement, a graph, or an interval notation, right? This is maybe the one thing that's going to be new to you guys, but the rest of it, the graph and the inequality statement, should be review. All right, so I'm just going to fill this entire page with examples of writing your answer as a statement, as a graph, and an interval notation, right? And that's the part that's going to be new to you guys. So I'm going to start over here, all right? If I have x greater than any number, right, I'm just going to let any number, I'm going to represent that with a, right? I'm just going to let a be a number. It can be any number. So if I have something like x is greater than a, right, I'm going to plot a on my number line. Any number that's bigger than a is going to be in this direction, right? These are where the numbers bigger than a are. And then if we remember, this is different from, say, the one right below it, which is x greater than or equal to a, right? X greater than or equal to any number a, all right? If I plot that, it's still going to be shaded in the same direction, but we aren't going to have the same exact behavior at a, right? So if we want to denote that it is a strict inequality, meaning if I were to plug a into this inequality, I won't get a true statement, I'm going to want to denote that with an open circle, right? If it is with equality, so if I plug in a greater than or equal to a, that is a true statement. So I am going to write a closed circle, right? And that's the biggest difference between the two, all right? So if I have greater than or less than, right, this is going to be an open circle. And if I have greater than or equal to or less than or equal to, this is going to be a closed circle. All right, the new part is going to be writing your answer in interval notation. All right, now in interval notation, going from left to right, on one end of your number line, if I go forever and ever to the left, you're going to get really big negative numbers, and I'm going to denote that as negative infinity. All right, and if you go forever and ever to the right of this number line, you're going to get really big positive numbers, which is going to take you to positive infinity. Now, writing your answer in interval notation is just from left to right. So I'm going to have my smallest value over here, that's a solution, is a, right? And then my biggest value, I can go really as big as you want in this example, right? So I'm going to go from a up to infinity. Now, to finish this, I would have to write parentheses around the infinity and parentheses around the a. This answer right here, this is our answer in interval notation, and that just means anything between a and positive infinity is a solution. And I put the parentheses over the a because parentheses means the same thing as an open circle. It just means you start there, but you don't include it as an answer, right? So everything bigger than a. Whereas the one right below it, right, I can write the same thing. I can say, going from left to right, well, the smallest value that's a solution is a, and the biggest, this is also going up to infinity, right? So negative infinity all the way up to infinity. The smallest one is a, right? Infinity is always going to have a parentheses, but to denote that we do include a, right, meaning a closed circle, I'm going to write a bracket, right? So then I have bracket a, comma, infinity as your answer in interval notation. All right, so with an open circle, you would have parentheses. With a closed circle, you would have brackets. All right, and I can do the exact same thing for x less than or equal to any number, right? Let's just say this is x is less than a, and x is less than or equal to a. right, I can still pick a number a on the number line. Anything less than a is going to be shaded to the left, right? These are the numbers less than a. And because it's a strict inequality, this is going to be an open circle. Because this one is with equality, it's going to be a closed circle, but still anything less than a is in the same direction. All right? Now, writing our answer in interval notation, starting from negative infinity, right, our smallest value that's going to be a solution is negative infinity, right? I can go infinitely large to the left, and you'll get a number that satisfies this inequality, right? So again, I'm going to do parentheses, negative infinity, right? It's going from left to right. And then our biggest value that's a solution, we're going to end at a, and because it's an open circle, it's going to be a with the parentheses. All right, so that's our answer in interval notation, and I can do the same thing with the one right below it. Right, so again, our smallest value that's a solution is going to be negative infinity. Our biggest, we end at a, and it's going to have a bracket because of the closed circle. All right? So maybe that's the only part that's new in this lesson. All right, and once we do more examples, you're going to see that it's really not so bad. All right, I'll try the same thing for these, right? So these last 4 inequality graphs on here are compound inequalities. All right, so these two, where the x is between a and b, these are compounds that are denoted with like an and, right? So you might have remembered these as like an and or an or. And if you see the word or in between, obviously it's going to be an or inequality, right? So these are compound inequalities. All right, so with the ands, let's say I have an a and a b, right? If x is between a and b, then I'm going to shade between these two values, right? And because these are both strict inequalities, I'm going to write open circle over the a and the b, all right? And then writing our answer in interval notation, going from left to right, our leftmost point is going to be a, our rightmost point is going to be b, and because these are open circles, I'm going to have parentheses, all right? So in red is my answer in interval notation, all right? I can do the exact same thing with the next one, right? So if I have a number a here and a number b right here, all right, because it's inequalities that have the equal sign underneath, I'm going to have closed circles here. And because x has to be bigger than a, it's going to be over here. And because x has to be less than or equal to b, it's going to be over here. So we're shading again in between, all right? And then in interval notation, going from left to right, our smallest value that's a solution is a, but because it's a closed circle, I'm going to put a bracket. The same thing with the b, because it's a closed circle, I'm going to put a bracket over that, and that's where we end, right? So it's going to be a to b with brackets, all right? Now with our or statements, again, I can have an a here, b right here. If x has to be less than a, anything less than a is in this direction, right? And because it's a strict inequality, I would put an open circle. Same thing with b, right? I would put an open circle over that b, and anything bigger than b would be in that direction, all right? So in interval notation, going from left to right, our smallest value would be at negative infinity, and then I would go up to a, all right? And because there's an open circle, I would put a parentheses, all right? Our next one would be b, going up to infinity, and because we have an open circle again, I would put a parentheses, right? The only difference here is that if I have 2 different intervals, I would put a u in between, right? That u denotes the union of 2 sets. Same exact thing with the next one, right? I'm going to plot an a and a b on these number lines, and once again, anything less than a would be in this direction, anything bigger than b would be in that direction. I would have closed circles because of the equal sign underneath. And then an interval notation would be from negative infinity up to a with a bracket, and then b to infinity with a bracket as well. And then once again, if I have 2 sets, I would join them with a u in between. All right, so it's a summary of what we would do in this lesson. Let's actually solve problems now. All right, so looking at this page, it doesn't look like anything super crazy. It doesn't look like anything you guys maybe haven't seen before from Algebra 1. All right, the only thing, again, like I said, is going to be putting our answer in interval notation. All right, so let's just start with this first one. Right, again, any inequality you can treat as if it was an equality, right, with an equal sign. All right, so something like 5x minus 7 is greater than 3x plus 9. I can just get the x to one side, so I'm going to subtract 3x on both sides, and then I can add 7 to both sides of my inequality symbol. All right, and then 7s are going to cancel out, 3x's are going to cancel out, and I'm left with a 2x is greater than 9 plus 7 is 16. And then lastly, we can divide both sides by 2, and I get x is greater than 8. All right, and this is our answer as an inequality statement. Now let's graph it on a number line. All right, so now I would plot a point at 8, and anything bigger than 8 is going to be shaded in this direction. Right, so any number bigger than 8 is going to be over here. Right, and because this is a strict inequality, I'm going to have an open circle. Right, so this is our answer as a graph. All right, and now writing our answer in interval notation, going from left to right, our leftmost answer is going to start at 8. Right, anything less than 8 is not a solution, so I'm going to start at 8. And it looks like anything in that direction is a valid answer. So we're going to go from 8 all the way up to infinity. Now, because there is an open circle, I would draw parentheses around the 8. And then, like I said in the previous slide, infinity is always going to have parentheses, whether or not it's an open or a closed circle. All right, so it's going to look something like this as our final answer in interval notation. All right, so now let's try the same thing over here. All right, so something like 7x minus 3 is less than or equal to 2x plus 7. Just like before, I can subtract 2x on both sides and add the 3. All right, and then the 3's are going to cancel out. Our 2x's are going to cancel out. This is going to get me a 5x is less than or equal to 10. Divide both sides by 5, and I get x is less than or equal to 2. And so this is our answer as an inequality statement. Now let's do the same thing on a graph, on a number line. All right, so I would plot a point at 2, right? Because this is with equality, right? I see that line underneath. This is going to have a closed circle, and anything less than 2 is going to be shaded in this direction to the left. All right, so this is our answer as a graph. Now in interval notation, going from left to right, our leftmost point, I can pick any number that's smaller than 2, and it would work in this inequality. So we're going to start at negative infinity, and again, infinities always have parentheses. And we're going to end at our biggest value, which is going to be 2. All right, and because that has a closed circle, I'm going to put a bracket, and this is our answer in interval notation. All right, hopefully not too bad. All right, let's do the same thing over here. All right, when you see a fraction in any of your inequalities, just like with an equal sign, you can get rid of it by multiplying by a least common denominator. Now our least common denominator here is going to be 2. So I'm going to multiply every single part of this inequality by 2, and that's going to get rid of that 2 on the bottom. So I'm going to get a 2 minus 3x, right, it's going to cancel out, is greater than or equal to 2x minus 8. All right, and then now I can solve this as normal, right? I can subtract 2x on both sides, subtract 2 on both sides, and I'm left with a negative 5x is greater than or equal to negative 10. All right, and then to get rid of that negative 5x, that negative 5, I can divide both sides by that value. And so I get an x on this side, a 2 on the other. Keep in mind, like we said on the first slide, dividing or multiplying by a negative, we have to flip the direction of this inequality. So it's actually going to be x is less than or equal to 2. All right, and then that's our answer as an inequality statement, right? Doing the same thing on a number line, I would plot a point at 2. Again, because it's with equality, I'm going to do a closed circle. Anything less than 2 is going to go in this direction. All right, so that's our answer as a graph. Now in interval notation, going from left to right, our leftmost point is going to start at negative infinity, right, with the parentheses, and then we're going to end at 2, right? That's our biggest value here, and because it has a closed circle, I'm going to put a bracket over it. And that's our answer in interval notation. All right, let's try the exact same thing with the next one. All right, so I'm going to multiply every single part of this equation, this inequality, by what's on the bottom, our least common denominator, which is 3. So let's multiply everything by 3, and then we get a 6 minus 5x is greater than 3x minus 18. All right, and then I would just solve for x, subtract 3x, and then subtract 6, and then we end up with a negative 8x is greater than negative 24, and then once again, when you're dividing by that negative, the direction of your inequality is going to flip. So this becomes x is less than 3. And this is our answer as an inequality statement. As a graph, right, plot a point at 3. All right, because this is a strict inequality, I'm going to have an open circle, and anything less than 3 is going to go in this direction. All right, and then in interval notation, going from left to right, the smallest value that we have is going to be at negative infinity, and the biggest is going to go up to 3, right, with a with a parentheses. All right, because it's an open circle, and that's our answer in interval notation. All right, so the only difference with this slide is that now we have compound inequalities, right? Compound inequalities just combine two inequalities together, either in an and statement, which is where you shade in between, or an or statement, which is where you shade in two different directions. All right, but it looks like all of these, I have the variable x in between two numbers, right? So we're still just going to solve as normal, right? So these inequality symbols kind of split up your inequality in 3 parts. So if I want to isolate my x, I can still just add 2 to all 3 parts of this inequality. So that's going to leave us with a negative 2 is less than or equal to 5x is less than 9. And then once again, I still have 3 parts here. I can divide every part of this by 5. And so I get a negative 2 over 5 is less than or equal to x is less than 9 over 5. All right, and now x is completely by itself. This is our answer as an inequality statement. Now on a graph, right, I would plot 2 points. It would be negative 2/5 right here, 9/5 right here. All right, over that 2/5 is going to be a closed circle because it has the equal sign underneath. Over 9/5 is going to be an open circle, right, because it's a strict inequality. And if x is between these two values, I'm going to shade in between. This is my answer as a graph. Now in interval notation, going from left to right, my leftmost value is going to be at negative 2/5. It has a closed circle, so I'm going to put a bracket, comma, my biggest value here is going to be 9/5 with a parentheses. All right, and that is my answer in interval notation. All right, so let's look at that next part of it over here, right? This next example. Once again, I see 3 parts. I'm just going to add 1 to every single part over here, and this is going to get me a negative 2 is less than or equal to 6x is less than 4. All right, and then we can divide every single part of this by 6, and then it looks like negative 2/6 is going to simplify to negative 1/3 is less than or equal to these 6's cancel out, x is less than 4 over 6 is 2/3. All right, and this is my answer as an inequality statement. So let me go ahead and draw this on a number line. I have a point right here at negative 1/3 and one at 2/3. And once again, over that negative 1/3 is going to be a closed circle because it's with equality. Over that 2/3 is going to be an open circle because it is a strict inequality. And then because x is between these two values, I'm going to shade in between. And then once again, I have a bracket over the closed circle and then a parentheses over the open circle. All right, and so this is my answer in interval notation. All right. Looking at this one, again, nothing special about this one. I'm still going to subtract 7 on all 3 parts of this inequality. And this is going to leave us with a negative 6 is less than 2x is less than 11 minus 7 is 4. All right, and then I can divide 2 to every single part of this. And this is going to get me a negative 3 is less than x is less than 2. All right, and so I can graph this, right? This is my answer as an inequality statement. My smallest value is going to be at negative 3. My biggest is going to be at 2. These are both strict inequalities, so I'm going to have open circles and x's in between them, so that's my answer as a graph. All right, and then from smallest to biggest, because these are both open circles, I'm going to have parentheses over both of these values. All right, so then in the interval from negative 3 to 2 is where our solutions are going to be. All right, so I can try the same exact thing with this last one. All right, again, if you see a denominator, you can just multiply by that denominator, and that's going to get rid of it. So I'm going to multiply everything here by 3. And this is going to leave me with the negative 12 is less than or equal to 2 minus 3x is less than 15. All right, so I'm going to subtract 2 everywhere. And so I get a negative 14 is less than or equal to negative 3x is less than 13. All right, and then divide everywhere by negative 3. And then negative 14 over negative 3 is going to become a positive 14 over 3. All right, and then keep in mind, when you're dividing by a negative, all of these inequality signs flip. So this is going to become greater than or equal to x is greater than 13 over negative 3 is negative 13 over 3, right? Neither of these simplify. All right, so this is a valid statement. We typically go from smallest to biggest though. So I can just rewrite this as negative 13 over 3 is less than x is less than or equal to 14 over 3. Right? This is always allowed, right? Even if I had something like 2 is less than x, right? X is greater than 2 is an equally valid statement, right? So these are exactly the same thing. So I can always reverse the inequality and it'll be exactly the same statement, right? So this is our answer as an inequality statement, right? So I'm going to draw a number line now. So negative 13 over 3 is my smallest value, 14 over 3 is my biggest, right? Over negative 13 over 3 is an open circle, and then over 14 over 3 is a closed circle, right? And then I'm going to shade in between. All right, and then in interval notation from smallest to biggest, the open circle is going to have a parentheses, so I get a negative 13 over 3. 14 over 3 is going to have a bracket because that has the closed circle. All right, so this is our answer in interval notation. All right, now when we're solving absolute value inequalities, we're going to isolate the absolute value, right? So similar to absolute value equations, you do want the absolute value completely by itself, all right? And if the absolute value is less than or equal to, it becomes an and statement, right? And we shade in between. So it might look something like that, or it might look something like that if it has closed circles. All right. If the absolute value is greater than or equal to, then it becomes an or statement. An or statement means it goes in one direction or it goes in the other direction, right? Same exact thing if it was closed circles with a greater than or equal to, right? So it can go in that direction or it can go in that direction. All right. One way to remember that is less than, we can say that this is less than, right? This is an and statement. And then greater than, we can say that this is great or than. Great or than. All right, so any greater thans are going to be an or statement, so you should expect 2 arrows. A less than is going to be an and statement. We can expect to shade in between. All right, so I want to solve these, graph them, and put them in interval notation. All right, so what I like to do with these kinds of equations is I like to treat the inequality as if it was an equal sign. All right, so if you remember with absolute value equations, what we did was we got rid of the absolute value bars. So I turned this into x minus 5, and I would say that this equals the original, and then I had x minus 5 equals the opposite of the original. All right. And then I would just solve these separately. So I can add 5, and then I get x is 7. Add 5, and I get x equals 3. All right? These wouldn't be my answers because I originally had an inequality, but I'm going to go ahead and plot these on a number line, right? 3 is going to be right here. 7 is going to be right here, right? If this is a less than, I can think of this as a less than, meaning it's going to be an and statement. So if it's an and statement, we always shade in between. So it's going to look something like that. All right, so I'm going to draw open circles because it's a strict inequality, and I'm going to shade in between because this is an and statement. All right. Now to write this in interval notation, going from smallest to biggest, I'm going to have parentheses because there are open circles, 3, 7. All right. And then this is my answer in interval notation. Simple as that. That's how we solve these kinds of problems. All right. Now I can do the same thing over here with this greater than, right? Remember, great or than. So I can expect my arrows to go in two different directions, right? So because it's with equality, I'll have closed circles, so it should look something like that. But again, let's just solve it. It's going to be x plus 3. I'm just going to pretend it was an equal sign, equals 7. And then I get an x plus 3 equals negative 7. Right? So I can subtract 3 on both sides, and I get x is 4. Subtract 3 on both sides, and I get x equals negative 11. Right? These wouldn't be your answers, right? But they would be helpful to plot on the graph, right? Negative 11 would be right here, and then 4 is bigger, so it would go right here. Because it's with equality, so I see that line underneath, I'm going to plot closed circles. And because this is an or statement, right, I know I'm going to shade in opposite directions. So it's going to look something like this on a graph, right? If that's confusing to you, what you can do is you can test points. All right, I know I'm uploading this video after I taught all the lessons. So if that's confusing, you can think of what we're going to do in the next lesson, right? So you can watch 1.8a and b, where we do test points, right? So I can test, right? This is going to split up. I can test 0, for instance. And then if I do 0 plus 3, right, the absolute value of 0 plus 3 is greater than or equal to 7, I get 3 is greater than or equal to 7, which doesn't work. So I know my middle section's not going to work, but my outer two sections will. Right? It's the same exact idea as we were doing quadratic inequalities. Again, I know I'm posting this video after I taught the lesson, so if you remember that and that makes sense to you, then feel free to do it that way. All right? Our answer in interval notation now, from smallest to biggest. My smallest value is going to start at negative infinity. And again, infinities always have parentheses, comma, negative 11. Right? That's where this first side of it ends. All right? I have a big gap right here. Now, again, like I said in the first slide where we were talking about interval notation, if I have two different intervals, I would join them with this big U, right? This union, all right? And then this new interval, right, this side of it, is going to start at 4, and it's going to go up to infinity, all right? So this would be my answer in interval notation, all right? And it's always how it's going to work. All right, so I'll try the same thing over here. All right, I have an x minus 20 is less than or equal to 4. So this is going to be an x minus 20 equals 4. And x minus 20 equals negative 4. So then I can add 20 on both sides. Add 20 on both sides. And so I get x is 24. And I get x is 16. Right, now again, those aren't going to be your answers, but they're going to help you graph your solutions, right? 16 is going to go first because it's smaller, and then 24 would go after. All right, keep in mind this inequality is a less than, so this is going to be an and statement, right? Less than, right? So if it's an and statement, I know I'm going to shade in between. All right, so if you're comfortable with that, what you can do is you can immediately put your closed circles and then shade in between. Right? If you're not comfortable with that, again, pick a test point and see, right? Again, the easiest one to test is 0, right? If I test 0, absolute value of 0 minus 20 is less than or equal to 4. We get the absolute value of negative 20 is less than or equal to 4. So 20 less than or equal to 4, that doesn't work. So that means this entire section doesn't work. The middle section does work, and the outer section does not work. All right, so this is our answer as a graph. And in interval notation, again, from left to right, it would be from 16 to 24. And because there are closed circles, I would put brackets around this, right? And that would be your answer in interval notation. All right, the only difference with number 12 is that now I have something on the outside of my absolute value bars, right? I do want to get that out of there. I want the absolute value bars completely by itself. So what we can do is we can divide both sides by negative 3. Right, and then doing that is going to get us the absolute value of x minus 1 is less than or equal to 5. All right. Why did I change the sign? Because we divided by a negative. Right, so that inequality symbol is going to flip. All right. So what I can do now is I can set up my two equations. I'm going to do an x minus 1 equals 5, x minus 1 equals negative 5. All right, so then I can add 1 to both sides. I get x is 6. Add 1 to both sides. I get x equals -4. All right, and then so those are points that I would plot on a number line. My smallest value would be a -4, and my biggest one would be a 6. All right, because this is a strict, I'm sorry, not a strict inequality. It has that line underneath. I'm going to have closed circles. And because this is a greater than, remember greater than, I'm going to shade on other directions, right? Opposite directions, right? I'm going to shade something like that. So I know I'm going to shade over here, and I'm going to shade over here. If you're not comfortable with that, pick a point, right? 0 is between these 2 points. And if I plug 0 into the original, I get -3 times the absolute value of 0 minus 1 is greater than or equal to -15. And so I get a -3 times the absolute value of -1 is greater than or equal to -15. Absolute value of -1 is just 1, and 3 times 1 is itself. So I get -3 is greater than or equal to -15, which is a valid statement. And so that means I made a mistake, right? I looked at the original, right? But you should be looking at this one when you're trying to graph, right? This is actually a less than, so it's going to be an ands, right? So it's actually going to shade in between, all right? So sorry, let me erase that. So this is actually going to get us, let me just redraw that, -4, 6, right? Close circles just like before, but we're going to shade in between. So this is going to be a less than, and we're shading in between, right? 0 does work in this interval, all right? And now in interval notation, it's going to be from -4 to 6, right? That's where our solutions are, and because we have closed circles, I'm going to have brackets, all right? And so that's my answer in interval notation, and that's essentially how you would solve absolute value inequalities. All right, now this entire page includes all special cases, right? Maybe it's non-exhaustive, right? And I'll show you a little bit more at the end of some special cases that you might see where there might be a little bit tricky, right? So if you need to, put a little star on this slide, right? Because this has some special things where things might work out a little bit differently. You get like stranger answers here, all right? Starting with this first one, 13. If I have -2 on the outside of my absolute value, I'm going to divide both sides by -2, all right? That part's not new, right? We did that in the previous slide, right? We just did that. So then I get the absolute value of x minus 1 is greater than or equal to -2, right? Again, dividing by a negative, you would flip the inequality, all right? Sorry, absolute value of x minus 1, all right? Now, before we even go to solve this, right, think about what the statement is saying. I have the absolute value of x minus 1 is greater than or equal to -2, right? A negative number, right? Think about what's in the absolute value. Now, no matter what I put in this absolute value, this is always going to be positive. So this is always positive. And that's one of the special things about absolute value. There's not a single number that I can plug into this absolute value expression here that's going to get me anything that's less than -2. So just look at the statement that you have, right? If this is bigger than or equal to -2, when is that true, right? Well, really, this is always true, right? So if it's always positive and a positive is bigger than a negative, then this is always true. Always true, right? So to denote always true, right, this is really going to have infinitely many solutions. There's not a single number that I can plug in here that's not going to make this a valid statement. Infinitely many solutions. And in interval notation, to denote infinitely many, it would be from -infinity to infinity, all right? So that's one special case, right? Now let me just pretend, right? So let me just do off to the side. Let's just say it was the absolute value of x minus 1 is less than or equal to -2. All right. Now, again, think about what this is saying, right? So here I have that this is always a positive, right? This is always plus. all right, is less than or equal to a negative, right? Can a positive ever be less than or equal to a negative, right? So, no, right? So that means this is false, right? This is always going to be false. So really something like this would have no solution. All right. Now one way to write no solution in interval notation is I would just write a little circle with a slash through it. Right? This is an empty set. There's nothing that I can put in interval notation that's going to get me a valid statement, right? Another thing that you could do, which I wouldn't really recommend this looks kind of awkward, is you could put brackets with nothing in it, right? Or squiggly brackets with nothing in it, right? Really, this is more mathematically proper, right? It just means that there's a set and there's nothing inside of that set, all right? Or you can do it this way, all right? Or you can very simply just write no solution, all right? So these are all valid ways to write our answer. All right, that's one special case. All right, our next one is another special case. Again, we want to get our absolute value bar completely by itself, and in this case it is. All right, so if I have the absolute value of x minus 1, think about what this is saying, right? Is less than or equal to 0, right? We'll think about what can go inside of the absolute value, right? Anything can go inside, and I'm always going to get a positive. So this is always positive. Always positive, that can never be less than 0, right? But look at this line underneath. I have that this is with equality, all right? Can an absolute value ever equal 0, right? And it can, right? If I have the absolute value of 0, that's just 0, right? So that does work. So really, this would mean that there's one solution. Let me write this again. All right, one solution where the absolute value is equal to 0, right? So all I have to do is I'm going to take what's inside of my absolute value and I'm going to set that equal to 0. There's only going to be one answer that's going to work, right? So the absolute value is never negative, but absolute value, right, this is allowed to equal 0, right? Absolute value can equal 0, right? And there's only one time that happens, and it's when you set whatever's on the inside equal to 0. So then when you solve this, I get x equals 1, right? So it's not even an inequality anymore, it's just x equals 1. And let's plot that on a number line, right? On a number line, it would really just be a point, a closed circle on 1, right? There's no arrows or anything, all right? Now in interval notation, we can write little squiggly brackets and write 1 like that. Really, you just get one answer out of it, all right? So I would honestly prefer what's more common to you guys is something like that. You don't need to worry about like squiggly brackets or anything, right? That's like a proper mathematical way to do it. But what's better for you guys is that you recognize that this just has one single answer, all right? Now let me try the same thing with the next one. Now this next one, I'm actually going to flip the inequality, just because we did something just like this, right? So this is the absolute value of something is less than or equal to 0. We already just discovered that this only has one answer, and that's when the inside is 0. Now let's just say, let me just erase that, and I'm going to turn this into a greater than or equal to 0, right? Think about when this is true. Well, what does this mean? This means that if this is bigger than or equal to 0, then this has to either always be positive, right? Or it has to equal 0, all right? And then it looks like this is actually always true, right? There's not a single number that I can plug into this absolute value that's going to get me something that's not true, right? It's always going to be greater than 0. And there's one answer where it is going to be 0, and this is going to be at a half, right? So where x equals a half, then this is going to equal 0, right? Any other number is going to get us a number bigger than 0, right? So it's positive, all right? So really, there's infinitely many solutions in this one, right? So this would be, again, on a number line, every single part of it, and in interval notation, right, if you look at the one above it, is it's going to be from negative infinity to infinity. All right, so this would have infinitely many solutions. Again, I just changed the inequality to make it a little bit different, right? So I made it like that. All right, now if you tried the same exact thing, but it was a strict inequality, now this inequality is telling me that this cannot equal 0. So this cannot equal 0. But I can have every other number. So really this would be our entire number line just without whatever makes this 0, right? And then this would be, if I do 2x minus 1 equals 0, I would get x is a half. And then at 1/2, I cannot have this be a solution, right? If I plug in 1/2 in for x, I will get 0, but this is a strict inequality. I don't have that line underneath. So really, I would have an open circle at 1/2, but everywhere else on the graph is fine, so I would shade everywhere else. Now, writing this in interval notation is a little interesting, right? So I go from negative infinity, but not to infinity, right? It would stop at 1/2, all right? I would need a little union because I'm also going to start at 1/2 and go to infinity, right? The parentheses means that I'm not going to have 1/2 as an answer, right? So you can split it up at a single point and have it be a valid answer, right? This is just saying that every single number in these intervals work except for 1/2, all right? So just some special cases for you guys to keep in mind. I know maybe they get a little bit tricky, all right? But these are some examples of what you might see, of what you might encounter with absolute value. And this is the only page where like interesting things happened, right? Everything else was pretty normal. And then maybe upon our reviews, we're going to go over maybe some more special cases, right? But this seems to cover majority of it, right? You can use this same exact reasoning that we were doing on this page for any special case, right? Now, if you look at the previous slide, right, and the slide before that, nothing really special happened there, because when there's a positive number on the other side, I just get a normal inequality where I get a range of values that work, all right? So hopefully that makes sense. We'll do some more practice together in preparation for your test, all right? But yeah.